Hello students, today we are going to see about linear block codes. It's a generator part. So linear block code is a channel code. So what is channel code? Channel code is one which adds parity bits to your message bit so that if there is an error, it can be corrected or at least detected at the decoder side. So linear block code is a type of a channel code. So there are many terms in linear block codes, but I feel we should first do the example, then all the terms will be very much clear. I don't believe in explaining the terms before and then taking the example, because I feel that if we take the example first, then terms will be automatically, you will imbibe all those terms very easily. So the examples will be they will give you the generator matrix. So code is generated by multiplying message with the generator matrix. So the generator matrix they will give you to you. So this is the generator matrix and the code is 7,4. So first understand what is this 7 and what is this 4. 7 is the length of this code. That means this code has the 7 bits and 4 is the length of this message. So message bits are 4 and code bits are 7. Now the generator matrix dimension uh, you have to remember. So how? This is 7,4. So the dimension of the generator matrix may be are 4 into 7. That means there are 4 rows and 7 columns. So it is easy. 7 4. So 4 7. Now the pattern is such that you have to first write in the generator matrix there is first identity matrix of dimension 4. So here you can observe up to fourth column there is a identity matrix. So this is your identity matrix 1 0 0 0 0 0 0 0 0 1 0 So this is the identity matrix. So right now, so till now we have seen they give the length of the code word and length of the message bits. So 7,4. So generator matrix is 4 into 7. So first is a ik means identity matrix of the dimension k means 4. After that there are parity bits. Now these bits can be different as per the generator matrix. So and there are 3 columns of the parity matrix. So this is 1 0 1 1 triple 1 0 0 triple 1. So they give this parity bits or the combinations of this parity combinations of the data bits so that parity will be generated. So right now we the important things are 7,4. So 4 into 7 identity matrix ik. Now so here it is represented like this. You will get a code word of bit 7. So C1, C2, C3, C4, C5, C6, C7, and the message bits are M1, M2, M3, M4 because 4 bits are there, and this is your generator matrix. You have to multiply the message with this generator matrix. You will get a one code word. So don't get confused. You are going to get the code words with the message. Now you know that there are 4 message bits. So how many combinations are there? In digital electronics you are expert to say if there are 4 bits, then combinations will be 16. So you will get the 16 combination of the messages. That means 16 messages are there. So you will get the 16 code words, or 16 code words are required, or valid code words we can say. Actually for the 7 bits the combination will be 2 raised to 7, but we are concerned with the messages are 4, so we are concerned with the 16 messages are 16, so we will get the codes we require the codes 16. So now there are many methods to solve this. In many books they will take the messages and multiply every time with the generator matrix, but the simple method I feel is that you have to create the equations. So that will be very easy to create the code words for each and every message. So you can observe here that mm, uh, matrix multiplication is like this. So if you have to multiply this row with this column, that means each bit so for you will get c1 equal to m1 into 1, m1 into 1 plus means here mod 2 means XOR operation, huh? So here all the operations are XOR. M2 into 0 XOR M3 into 0, this 0, M4 into 0. So you can get this 0 will become 0, this will be 0, this will be 0. So C1 equal to M1. So this C1 you got it as M1 only because there is only 1 at this position. Next, what is C2? C2 will be this into this column. So M1 into 0 XOR M2 into 1 XOR M3 into 0 XOR M4 into 0. So that will be M2 only because 0 will be cancelled. Now what is C3? C3 is equal to this row and third column. So M1 into 0, M2 into 0, M3 into 1 plus or XOR M4 into 0. So that will be M3. C4 will be M4. Now let us see what is C5. C5 will be M1 into 1 XOR M2 into 0 XOR M3 into 1 XOR M4 into 1. So where R ones are there, so M1, then M2 is 0, here it is 0. So M1 XOR M3 XOR M4. So C5 is M1 XOR M3 XOR M4. C6 is, you can now by observing you can write the equation. C6 is equal to here M1 M2 M3. So M1 XOR M2 XOR M3. So what is C7? So C7 is, here is there M2 XOR M3 XOR M4. So first in linear block codes you have to write these equations, then it will be easy to prepare the table of the messages and code bits. So next next you have to build the table. So the M1 M2 M3 M4, so 4 bits are there, 16 combination, as you are very much well known with this table of the 4-bit 16 combinations. Now here the code, so the C1 C2 C3 C4 C5 C6 C7 are the 7 bits of the code word. So this is one code word, this is second code word, this is third code. All these are code words, and this all 16 code words form a code. So all these are code words, and these 16 these vectors form a code. So uh, so how to so all these equations are written once again here. So C1 is M1, so write down it as M1. C2 is M2, so this is M2. C3 is M3. C4 is M4. C5 is M1 XOR M3 XOR M4. 0 XOR 0 is 0. 0 XOR 0 XOR 0 is 0. Then again C6 is M1 M2 M3. That means these three 0 0 0. So this is again 0. C7 is M2 M3 M4. So 0 0 0, that will be 0. So XOR is, you know na, XOR is 0 XOR 0 is 0. 1 XOR 1 is 0. 0 XOR 1 is 1. 1 XOR 0 is 1. Okay, so let us take some different examples. So let us take this one. So this is the message. So C1 is M1, so we have copied M1. C1 is M1. C2 is M2. M2. C3 is M3. 0. C4 is M4. Now what is C5? C5 is M1 XOR M3 XOR M4. So C5 is M1 XOR M3 XOR M4. So M1 1 XOR 0 is 1. 1 XOR 1 is 0. So that will be 0. Then what is C6? C6 is M1 XOR M2 XOR M3. C6 is M1 M1 M2 M3. So 1 XOR 1 is 0. 0 XOR 0 is 0. So again it is 0. Then C7 is M2 XOR M3 XOR M4. So C7 is these three. 1 XOR 0 is 1 and 1 XOR 1 is 0. So that is 0. So it is very easy. Another very easy clue is, suppose. So let us take this example. So for first 4 bits you have to copy this. So you can see first 4 bits are like data bits 11110 because there is a identity matrix. So you have to copy as it is. So here you can see first up to C4 the message bits are copied. So here 400001 0010. Likewise here also 4 bits you have to copy and complete up to C4. After that you have to see the combinations for C5. For C5 you have to take M1 M2 M1 M3 M4. M1 M3 M4. So what is M1? M1 is 1 in this example. 1 M1 is 1, M3 is 1, M4 is 0. So don't do the XOR operation all the time. See how many ones are there. The ones are even, that is 2. So if ones are even, then answer will be XOR operation of this will be 0. So you got here 0. So that is very easy method than doing XOR every time. So after that let us see C6. For C6 you have to take these two, M1 M2 M3. You have to take these three. C6. So C6 1 1 1. So odd ones are there, so answer will be 1. Here 3 ones are there, so odd ones. After that C7 is M2 M3 M4. That means these three M2 M3 M4. So 1 1 0. So even ones, so answer will be 0. So 0. That means if odd ones are there you have to write 1, even ones are there you have to write 0. So that will be a very fast method to complete this table. So what is the clue? That means you have to copy the message bits up to C4. Then C5, C6, C7 you have the equations. See how in which bits there is a XOR. So for C5 you have to take M1, M3, M4 and write it like this 110 M1, M3, M4. See how many ones are there. If those are even, then write it as 0. And if those are odd, then write it as 1. Write it as 1. For again let us take another example so it will be more clear to you. So let us take here 0 0 1 0. So this is message. So first 4 bits of the code are same 0 0 1 0. Then next bit is M1 M3 M4. So M1 is 0, M3 is 1, M4 is 0. So 0 1 0. So one odd ones are there, so 1. Then C6 is M1 M2 M3. So these three 0 0 1. So odd ones 0 0 1, these three. So there is odd one, so write it as 1. Then C7 is these three M2 M3 M4. Again odd ones are there, so write it as 1. So this is your code for this message. So So let us check whether we are correct or not. So 0 0 1 0 0 0 1 0 is this one, correct, right? So it's very easy to prepare the table by this method. Because if you are going to do the XOR every time, there is a chances definitely there will be chance that you will skip or you will skip or forget any of the XOR operation and your answer will be incorrect. So next term is Hamming weight. Hamming weight is we have already seen in one video where we are discussing about the terms of the linear block code. So Hamming weight is nothing but you have to count the number of ones in that code. So here 0, here number of ones are 1 2 3, so that is 3. Here number of ones are 4, 1 2 3 4. So Hamming weight is like this. You have to write the Hamming weight. Why you have to write the Hamming weight? Because you have to find the Hamming distance, and in linear block code minimum Hamming distance is equal to minimum Hamming weight of non-zero code word. So here the minimum Hamming weight of non-zero code word is 3. Minimum Hamming weight of non-zero code word is 3. So you might be asking why not 0? Because you have to see the minimum Hamming weight of non-zero code word, and 0 is the Hamming weight of 0 code word. So why we are writing the Hamming weight? Because we need the minimum Hamming distance. Minimum Hamming distance, then we found it as 3. Then why minimum Hamming distance is required? Minimum Hamming distance is required because we have to see how many errors this code can detect and how many errors it can correct. So the number of detectable errors TD is less than or equal to D minimum minus 1. That's why we are finding the D minimum and Hamming weight. TD is less than or equal to 3 minus 1. 3 is D minimum. So TD is less than or equal to 2. So this code can correct 2 errors maximum. This code can detect 2 errors. Now number of correctable errors are TC is less than or equal to D minimum minus 1 by 2. So that is 3 minus 1 by 2. So TC is less than or equal to 1.5. This code can correct 1 error maximum. So this code which is having 7 bits in the code and message bits are 4, having D minimum equal to 3, it can detect 2 errors and correct 1 error. Now let us see what are the properties of linear block code. So linear means if you do linear combinations of these code words, linear combination of these code words, you will get another code word which is among these code words. For example, if you do the addition of this code word, and this code word, you will get answer which is there in this code only. So that is linear combination of any two code words is a valid code word. So valid code word means what? In simple language, this is your table which is called code. If you do the combinations of these code words, you will get another code word which is also there in this table. So that is nothing but a valid code word. Okay, so for example, a linear combination of code word is a valid code word. That means if you there is one code word we have taken from that table, another code word we have taken from that table. So 0001101, 0001110, this code word we have taken. Then another code word what we have taken, 00101111, 001011. So we have taken this code word and this code word, and we done the addition of these code words. Again, addition is not the binary addition, it is the XOR addition. So if you add this code word and this code word, you will get another code word. So that is 0011010, 00 so you got 0011010. So this code word is also in this table, so that is why it is called linear code. So linear code, that is the definition of the linear code, that linear combination of code words is a valid code word, and all zero code word is always a valid code word. So always in this table you will get the all zero code word. So this is code, this table is nothing but a code, and you will get always a all zero code word. Again, what is again property of the linear block code? That is minimum Hamming distance. So how, in linear block code, how to find the minimum Hamming distance? Minimum Hamming distance, you don't have to do the combinations of all the code words. You just have to find the Hamming weight and see what is the minimum Hamming weight of non-zero code word. That is nothing but the minimum Hamming distance. So what is Hamming distance? That is explained in the previous video, where we have explained the terms of linear block codes. So you can just check that what is minimum Hamming distance. So I hope you got the feel of this generation of linear block code. So in next video we will see the decoding part, or we can take another example of 6,3 linear block code and generate the all the code words of a code. So that's it for this video. Thank you.